All right, so this week we're going to take a look at what's called unit circle trig, okay, section 2.2 in our book. And I'm going to start off with this diagram. Okay, so what I've drawn here is an xy axis. Okay, and on that axis I put a circle centered at the origin. Okay, and as we go around the circle, the positive x-axis, that direction is 0. Positive y-axis is 90. Okay, once we get halfway around to the negative x-axis, that's 180 degrees. Okay, negative y-axis is 270. And then all the way back around, we're back at 0 or 360. Okay, now this diagram here is specifically a unit circle because I labeled the radius length 1. Okay, so everything that we do today and tomorrow is going to be based off using this diagram, which is just a circle with a radius of 1. It doesn't matter if it's 1 inch, 1 foot, it's just 1 unit. Right? And the goal is basically to figure out a coordinate that represents an angle. Okay, every single angle that we're going to deal with, and we're not going to deal with every possible angle, we're only going to deal with a few of them. Okay, but every angle that we deal with can be represented as a coordinate on the unit circle. Okay, and we're going to start by figuring out the 4 coordinates for 0, 90, 180, and 270. Okay, so let's start with 0 degrees. Okay, here's the coordinate for 0. This is the origin at 0, 0. If we went right 1 unit, anybody tell me what the coordinate would be if you started at the origin and just went straight to the right 1 unit? Yeah, go ahead, Dan.
1, 0.
Yeah, 1, 0. That's the coordinate for 0 degrees, right, on the unit circle. It's just right 1 unit. Okay, how about for 90 degrees? Anyone think they can tell me a coordinate for 90? Yep, Paige?
0, 1.
Yeah, it's just up 1 unit, and that's 0, 1. Okay, Skylar, how about the coordinate for 180?
Negative 1, 0.
Yeah, 180, all you're doing is going left. Okay, and again, 1 unit. And lastly, the coordinate for 270. How about Sam?
0,
0. Oh, do we have 2? Yeah. Yeah, I'm sorry. Yeah, 0, negative 1. Okay, any questions on those coordinates? Right, so those are the 4 easiest coordinates to find. Okay, these coordinates 0, 90, 180, and 270. Okay, so we'll come back to using these coordinates. I'll show you what we do with them. But if you can't figure out the coordinate for your angle, you're stuck. You have to be able to figure out what we just did. Okay? Right, so as we measure angles on the circle, okay, remember there's 2 different directions we can measure an angle in. We can measure clockwise and counterclockwise. If you measure an angle counterclockwise, that's positive. If you measure clockwise direction, that's negative. Okay, and the reason that's important is because sometimes they might give you an angle, say like 90, and you're going to have to figure out the coordinate. So if you're not sure, step 1 is to graph it. And if you're going to graph it, you have to know what direction to move. Okay? So positive angles, counterclockwise. Negative angles, clockwise. All right, so because we can go in two different directions, sometimes that gives us multiple ways to describe an angle. Okay, so let's say I had 270. Put it right about there. Okay, the way that I went was counterclockwise, right, to get to 270. Anybody think they could tell me what it would be as a negative angle? Okay, instead of going counterclockwise, what if I went the other way? How much would I have to go? Yeah, Sam? Yeah, negative 90. Negative 90 and 270 are exactly the same thing. Okay, they both land at the same spot. Any questions on that fact? All right, so now the question is, anybody see what we could do to make an angle that's negative positive? Because we don't usually like to work with negative 90. I would rather work with 270. But there's something you can add to negative 90 to make it positive and turn it into 270. About Nick?
360.
Yeah. If he wasn't sure, my hint was going to be do this. Go around one time and stop right back where you started. Okay? And when you go around one time, you add 360. Okay? So that's one way we can make negative angles positive. What about if I had something like this? I had the angle 990. Okay, visually, you all can see where it is. But let's just say on paper, I gave you 990. Any thoughts on how you could make this smaller? Make it something more manageable to work with? What do you think you could subtract from it? About Nolan?
I have no idea.
Well, what could you subtract? Think about moving on a circle. What could you subtract in degrees that would bring you back to the exact same spot?
90.
Well, if you did 90, it would move you like that. It would move you a quarter of the way around the circle.
990.
Not quite. Want to help him out? What can you subtract, or how much can you move on a circle and end up right back where you started? You have to know how many. Yeah, 360 degrees. All right, so if we subtract one revolution, I end up back right there. Now I have the angle 630. Okay, it lands in exactly the same spot, but 630 is a little smaller. Still too big. Okay, so I'm going to do it again. Now I get the angle 270, and that's something we should be familiar with. Okay, so the trick, anytime you have an angle that's over 360, we want to make it smaller. Or if we have an angle that's negative, we want to make it bigger. Okay, we always want to deal with angles between 0 and 360. That makes it easier. Okay, so to take a big angle and make it smaller, you can subtract 360 as many times as you need to until you finally get an angle between 0 and 360. Because the whole point of unit circle trig, we don't care how many times we've gone around the circle to get to a point. All we care about is where did we stop. That's all we need to know. Okay, and the same thing to take an angle that's negative and make it positive. Just keep adding 360 until you finally get the angle between where you want it, 0 and 360. All right, so let's say we had negative 842 degrees. I want to write that as a positive angle. Okay, so Katrina, what would I do to write that as a positive angle? Okay, I'm going to add 360. Adding 360 brings me right back to where I started. Just going to make it less revolutions. Okay, it's still not positive, so what would I do now? Do it one more time. Still not positive, so one more time. Okay, so negative 842 degrees is exactly the same as 238 degrees. We just add 360. In this case, we had to do it 3 times. Now, this is not an angle we would probably work with unit circle trig. 238, it's kind of a messy number to work with. We're generally going to work with angles that are multiples of 45 and multiples of 30. Okay, what about if I had 1,250 degrees? Rebecca, how would I make that a smaller, more manageable angle to work with? Yeah. Okay, I have no idea where 1,250 degrees is. But if I subtract 360 a couple of times, I can tell you where 170 degrees is. I know if I'm looking at the circle, 170 is about right there. Just a little bit shy of 180. 180 is halfway. 170, a little bit before it. Okay, but I didn't know that looking at 1250. It was too big for me to kind of think of in my head. Okay, so any questions on doing what I just did right there? All right. So next thing we're going to look at is our 6 trig functions. Okay? This will be the first time in this class we've talked about what a trig function is. Okay, so in algebra, you have different kind of functions. Okay? Square root, that's a function. Squaring is a function. Can anybody name another function from algebra? And how about Kyle? Can you think of any other functions from algebra? What is it? Okay, that's a notation for a function, but it's something you'd plug a number into. Logarithm is a function. I'm taking all the answers. Anybody think of anything else? Exponentials. Okay, those are functions. Those are all different kinds of functions. Well, in trig, we have 6 basic functions we deal with quite a bit. Does anybody know, maybe from either geometry or if you did in Algebra 2 a little bit, what some of the trig functions are that we deal with? Yep, Sam? Yep, tangent is one of the 6. Cosine? It's 2. Yep. Sine. So sine, cosine, and tangent. Those are the 3 basic ones we deal with. And then we deal with each one of them flipped. They're reciprocals. Does anybody know what those 3 are? Yeah? Cotangent is one of them, yeah. And secant and cosecant. Okay, so those are going to be our 6 trig functions. And the definitions that I'm going to give you are going to be based on unit circle trigonometry. So if you've done like opposite, hypotenuse, adjacent, if you've done that before in geometry, that's not this. Okay, this is a little different. Okay, so here's the first 3. Sine, which we abbreviate SIN, cosine, COS, tangent, TAN. Okay, and these definitions are all based on knowing the coordinate for the angle you're working with. So you have to be able to figure out that coordinate. Okay, so when we have a coordinate, it's made up of 2 values. Marquise, what do we normally call the first value in a coordinate? Yep, and the second? Y. Okay, so if I go back to my unit circle diagram, You might have some point right there, okay? And it has an x and it has a y value. Okay? We don't know what the x and the y value are, but our goal is to figure them out. And they're going to give you some information in the problem to be able to do that. All right, so once you figure out your coordinate, which we're going to talk about a little bit, if you want to know the sine, okay, the sine is just the y value of your coordinate. Okay, you don't even need the x for sine. If you want to find what's called the cosine, take your coordinate and just tell me the x value of it, and that's the cosine of the angle. And lastly, if you want the tangent, this time you need both the y and the x, and you divide them. Okay, so tangent is y divided by x. And here's the other three. What's nice about these three is if you already know the three on the left, the three on the right are pretty much the same thing, just flipped. You just flip each one of these. Okay, just to show you the abbreviations, cosecant is CSC, secant is SEC, and cotangent, COT. So I said, to get the three on the right, all you have to do is take the three on the left and flip each one. If we look at y, though, that's not even a fraction. How could I make that a fraction so I could flip it? Yeah, just put it over 1. It'd be y over 1. So if we take that and flip it, that's the cosecant. So anyone think they can tell me what the cosecant is? Yeah.
1 over y.
Yeah, it's 1 over y. Great. Same thing with the secant. Take the cosine, pretend like it's a fraction, and flip it. Okay, so Shannon, do you think you can tell me what my secant would be?
1 over x.
Yeah, very good. 1 over x. And my cotangent, take the tangent and flip it. Okay, so Selenia, what would my cotangent be?
X over y.
X over y. Yeah. And those are the definitions of the 6 trig functions based on a unit circle and a coordinate. Okay. So what I usually do is I always memorize the 3 on the left, and if I know those 3, just remember you flip them and you get the 3 on the right. Okay. Okay, those 4 angles that we dealt with earlier, the 0, 90, 180, and 270, because each of those angles are on an axis, they have a special name, and they're called the quadrantal angles. Because they're right on the boundary lines, the axes, which separates things into quadrants. These are the 4 of the angles we're going to work with this week. As I said earlier, some of the other angles we will work with today, more tomorrow and Wednesday. Multiples of 30, like 30, 60, things like that. And multiples of 45. And so if you ever see a question that says something about what are the quadrantal angles or asks you a question, now you know what they are. All right, so how do we actually do unit circle trig? Okay, so I've explained to you what the definitions are. Now I'm going to explain how you use those definitions as part of this process. Right, so if you want to find a trig function for some angle, okay, the first step is you have to find the point. So if I tell you, okay, we're going to work with a 90-degree angle. Well, that's great that I'm telling you it's a 90-degree angle, but 90 degrees doesn't help you. You need the coordinate for 90 degrees. That's step one. Okay, or 80, or whatever the angle happens to be. So find the coordinate on the unit circle that represents the angle you are being told to work with. Sometimes they'll give you that. Okay, in the first few problems that we do, I'm going to give you a point. Okay, you're not going to have to worry about finding it. We'll get to some problems towards the end where you do need to find it. Okay, so step one, finding the coordinate. Step two is using the definitions that I just gave you on the other page. Okay, find your coordinate, and then plug it in to the 6 definitions I just gave you on the other page. Okay, so if they wanted, let's say they wanted just the sine, if that's the only one out of the 6 they wanted, I would plug in and I'd use my y value. Okay, if they wanted just the cosine, I'd be using just my x value. If they wanted the tangent, I would write down y divided by x, circle it. That's my answer. Okay, what we'll do to start out is I'm going to do all 6. Okay, we'll practice finding every trig function in all the problems we do. Okay, so for the first one, I'll leave the directions up there while we look at the problem. Okay, so for example 1, all you really need is the coordinate. I'm just explaining what the coordinate is. Okay, but all you need to really write down is the coordinate, -1/2 square root 3 over 2. Right, so Jared, in example 1, are they giving me the coordinate, or do I need to find it myself? Yeah, they're giving me a coordinate. Now, this coordinate has numbers in it we didn't see on this page anywhere. It doesn't have any zeros or anything like that in it. So, do you think this is the coordinate for one of the quadrantal angles? Eric, what do you think? No. The coordinates for the quadrantal angles are all zeros and ones. What is this the coordinate for? We're never going to know. Okay, tomorrow we will. Okay, but it's a coordinate for some angle somewhere on this circle. But it's not the coordinate for 0, 90, 180, or 270. Okay, and as I said, you won't know what it is today. All I want to do is take that coordinate and plug it into all 6 definitions. Okay, I want to find the sine, the cosine, and the tangent. Okay, start with those 3. All right, so Jake, if we look at that coordinate, which is my x value and which is my y value?
1/2 is your x value,
Yep.
and square root 3 over 2 is your y value.
Perfect. That's my x, and y is square root 3 over 2. Okay, Shakira, what is the definition of sine? What's it equal to?
Y.
Yeah, it's equal to y. So in this case, the sine is square root 3 over 2, and that's it. That's all you have to write for the sine. Okay, Jesse, what's my definition of cosine?
X,
X. And in this case, x is
negative 1 over 2.
-1 over 2. Sine and cosine are the easiest two to find. Okay, you don't have to do any arithmetic at all. Okay, now let's look at tangent. Paige, what is the formula for tangent?
A y over x.
Y over x. All right. So y is square root 3 over 2 divided by x. Okay, so that's my tangent, but we got to simplify that. Okay, we can't leave it as a fraction over a fraction. Does anybody see what's going to cancel out? Right there, yeah? Yeah, the 2's cancel out. Some people don't do it that way. Maybe you do it this way, where you flip and multiply by the reciprocal. So take the one on the bottom, flip it. Well, if you flip and multiply by the reciprocal, the 2's are still going to cancel. Okay, it comes out the same way. Okay. So I have square root 3 divided by -1. That's negative square root 3. Okay, another thing when we're doing unit circle trig is we do not write any decimals, right? Well, I mean, -1/2 is a decimal, but we leave everything as a fraction, okay? Or a root. Okay, we don't do anything with those. All right, CSC. Katrina, do you remember what CSC stands for?
1 over y.
Okay, so formula is 1 over y. How about just the pronunciation?
Oh, cosecant.
Exactly, each syllable, cosecant. Very good. And it's 1 over y, which basically just means take y and flip it. Right? That's what 1 over means, flip it. Right, so Marquise, what do I get if I flip that?
2 over 3 square root.
2 over, how do you say it?
Square root of 3.
Good job, 2 over square root 3. Now, is that okay as a final answer? No, what's wrong with that, Sam? Yeah, we can't leave that square root in the bottom, so that's why last week we talked about how to fix that. Does anybody remember how we fix that? How do we get that square root out of the bottom? If it ends up in the top, that's okay. Sam? Yeah, we're going to times it by the square root of 3 on the top and on the bottom. So can you go ahead and tell me, Sam, what I get in the top?
You get 2 square root of 3.
2 square root of 3 in the top. And how about the bottom?
3.
Right. Square root of 3 times square root of 3 is the square root of 9, or just 3. Do not find a decimal. Just leave it like that. Okay? Okay, so those are the ones that are a pain to do. When you have one that has a root in the top, because when you flip it, it's going to go to the bottom. Next one's not as bad. To get the secant, we're going to flip -1/2. Nolan, what do you get when you flip -1/2?
2 over -1.
Yep, which if you simplify would be, yeah, just -2. That is the secant. And the last one is the cotangent. Right, how about Kyle? This time I don't have a fraction here to flip, but I can always put it over what number if I want?
1.
Yeah, we could always just put over 1 like that. And what do you get when you flip that?
1 over square root of 3.
Yep. It doesn't matter if you keep the negative in the bottom or the top when you flip it, as long as you keep the negative somewhere. And we're going to have to do the same trick this time. To fix the square root being in the bottom. And can anybody tell me what I get when I simplify that?
Square root
Yeah.
of 3 over 3.
Square root, close.
Isn't the square root here on top? Was it negative?
Negative, yes. So negative square root of 3 over 3. Now on the test, this would be 6 problems. Each answer would be its own problem. I'm not going to ask you to do all 6 in the same problem. Okay? Hey, questions on that? Okay, so again, we're finding the sine of, this is an angle. We have no idea what angle we were working with in this whole problem. But we don't need to know. All we need to know is where the angle is. Okay? I don't need to know what it is. Could I find what it is? Absolutely. I could look at that and that's enough information to tell me what this angle is. But that's not what we're doing this week. All right, let's try this one. Okay, it says find the 6 trig functions. And how about Claire? Is this a problem where I need to find the coordinate, or are they giving it to me? Yeah, they're giving it to me again. This is your coordinate. Okay, does anybody think that that's the coordinate for either 0, 90, 180, or 270? No. How do we know that that definitely is not the coordinate for 0, 90, 180, or 270? Yeah? Yeah, the coordinates for the angles I just mentioned have all 1s, 0s, and negative 1s. So what is this the coordinate for? We don't know. Or you might know. Does anybody have a guess what angle that might be? If you go right on the x-axis and up on the y-axis, the same amount? It is. That is the coordinate for a 45-degree angle. How would you get that? You don't have to worry about that today. Okay, that'll be tomorrow. Okay, but if you really wanted to know, it is the coordinate for a 45-degree angle. Okay, so again, you don't need to know that. We just need to plug it into the formula and figure out all 6 trig functions. All right, so how about Alyssa? Can you tell me my sine?
Square root of 2 over 2.
Yeah, because we have a couple of those. Can you tell me, did you pick x or did you pick y?
No, I'm sorry.
Well, you would get lucky this time because they are the same. But yeah, you have to pick the y value. Okay? So sine is the y. Jake, how about my cosine?
Square root of 2 over 2.
And again, did you pick the x or the y?
Yeah.
Yeah, cosine is the x. And now tangent, take y and divide by x. Okay. Brian, what do you get when you divide y by x?
1
How'd you do that so quick? There's all these roots and fractions. How'd you do all that in your head?
is the same.
Yeah, they're the same thing. Y is root 2 over 2, x is root 2 over 2. If you divide two things that are the same, you get 1. All right, John, can you tell me what do I do to get my cosecant? And what did you do? So did you take something and how'd you get that? No, not y over x. How do we get cosecant?
We flip the sign.
You flip the sign. Okay. Take the sign value, flip it. So it's 2 over root 2. And as we go, you'll probably get pretty quick at fixing these so the root's not in the bottom. Was anyone able to fix it and tell me what you get for an answer without a root in the bottom? Yep, Shakira.
I get the square root of 2.
Yeah, it is just the square root of 2. Okay. Would anybody like me to show you how you get that? Everyone You okay with that? Okay. How about the secant? Oh, Brianna, what would the secant be?
You want the answer, or you want, how you do it?
Just the final answer.
Square root
Yeah. And how come you can do that one so quickly?
2. Because you do the same thing on the top, uses every times the sine, you'll flip it.
Yeah. So to find the secant, you're going to flip the cosine, but the sine and the cosine are the same. So we already know the answer when you flip sine, so it's the same answer when you flip cosine. Right, and the last one, my cotangent. Dan, what do you get when you flip 1? 1. Okay, so those are your 6 trig functions for actually a 45-degree angle, but you don't need to know it's a 45-degree angle today. All you need to know is that that's the coordinate. Hey, questions on that one? All right, why don't you guys take like 5 minutes. Here's your coordinate. Do the same thing we just did with this coordinate. Okay, find all 6 trig functions. If you get stuck, I'll come around and help you out. And this will probably be the last one we do of this type. Okay, then we'll move on. All right, so this is the kind of problem, again, they're giving you a coordinate. We haven't done any where you've had to find it. Okay? But if you have to find a coordinate, okay, at least for today, it's got to be something simple. Okay, because we don't know how to find coordinates for anything other than the 4 angles I showed you. All right, so we've got our coordinate. Let's start off with the sine. So how about, Nick, did you get the sine here?
Negative 1/3.
Yeah, it's just the y value. Okay, so negative 1/3. Marquise, how about the cosine?
2 square roots of 2 over 3.
Good job. 2 square roots of 2 over 3. You don't have to do any arithmetic for those two. Brianna, you don't have to tell me the final answer for tangent, but how did you do it?
I take 2 square root 3 over, or negative 1/3 over 2 square root over 3.
Yeah, so negative 1/3 divided by 2 root 2 over 3. And I can take the one that's in the bottom, flip it, and multiply. But what's going to end up canceling out? The 3's are gone. Okay, so now I have negative 1 over 2 root 2. And what do I have to multiply top and bottom by to fix that?
Square root 2.
Yeah, square root of 2. So square root of 2 over square root of 2. That's going to give me negative 1 times the square root of 2 in the top, divided by, what's my denominator? What is it?
4.
Yeah, it's just going to be the square root of 2 times the square root of 2, which is 2, times another 2. There's my answer. Negative square root 2 over 4. But don't get rid of this answer that you had right here. There's nothing wrong with that answer other than the fact there was a root in the bottom. I'm going to come back to that answer in a little bit. Okay, cosecant, that one's quick to find because we just flipped negative 1/3. Okay, my secant. Anybody tell me what you got there for a final answer? Sam?
3 square root of 2 over 4.
3 root 2 over 4. Anybody else get that? Let's just take a quick look off to the side. When you flip that, you get 3 over 2 root 2, and then multiply top and bottom by root 2, and you get exactly what you said. It's perfect. And my cotangent. All right, so I have two choices. I can either take the answer that I circled for tangent and flip it, or let's go back to this answer. That's the same thing as what I circled. The only reason I didn't use it is because the root was in the bottom. But why might I want to use what's in the dotted circle when I flip? It's not wrong to use what's in the solid circle, but this one's going to be faster. Yeah?
Because you'll have to simplify the thing, because it'll be in the top, so it won't matter.
Right. If I take and flip this whole fraction, the root goes to the top, I'm done in one step. -2 root 2. That's it. If I take the original one I had and I flip that, now I've got the root 2 back in the bottom again, and I got to go through the whole process to fix it. And if you do, you're just going to end up with what I have right here. Hey, did anybody notice to do it that way? Flip what was in the dotted circle? Maybe a couple people. If not, and you flipped it the other way, hopefully you got the same thing with a little bit more work. All right, so any questions on the type where they give you the coordinate? All right, so let's try this one. Okay, the question says, find the 6 trig functions for 90 degrees. Okay, Karen, what's different about this problem than the last 3 that we did? It doesn't give me the coordinate. Okay, it's great that they're telling me 90 degrees, but if I can't figure out the coordinate, I can't do anything they're asking me to do. So the first thing I'm going to do is draw my diagram, and I'm going to figure out where 90 degrees is. Okay. Where's 90 degrees? Is it right, top, left, or the bottom? It's the top. And does anybody remember what the coordinate was for 90 degrees? Yeah, Selenia? 0, 1. Now this problem is just like all the others. Now you've got your coordinate. Okay, so Nolan, I got my coordinate. What's the sine of 90 degrees? So I've got my coordinate, and now I want to figure that out.
1.
Yeah, it's my y value, okay, or 1. Okay, Alyssa, how about cosine? Not sure. What's the definition of cosine? Cosine is equal to what letter? No, not y, that's sine. X, yeah, it's equal to x. And what's x in this case? No, just literally just x. Yep, don't have to flip anything yet. Okay, so cosine is 0. And Katie, what about my fraction for tangent?
1 over 0.
It's 1 over 0. And what do you get if you do 1 divided by 0? You can't. So what do we normally write when you try to do that? You can, yeah, can't divide by 0, or is another word, begins with a U. Yeah, undefined. Okay, we can't do that one. All right, so when you're dealing with trig functions that have a 0 as one of the coordinates, it is possible you get undefined. Okay? Cosecant of 90. How about Kyle? What's my cosecant? 1 over 1, which is just 1. Okay, how about my secant? Anyone think they know? Be careful with this one. We've seen it happen before, but yeah. Karen? Oh, I'm sorry, Paige? Not sure. Yeah, Sam? This is undefined. Can you explain why that one's undefined?
Because it's 1 over 0.
Right. If you were going to make this a fraction, you could put 0 over 1. Now flip that. you get 1 over 0. We just said divide by 0 is undefined. And the last one, cotangent of 90. That one's not undefined. What would be, what's the fraction? Yep, Dan? It's 0 over 1. That is perfectly fine to do. You get a number when you do that out. What's 0 divided by 1? 0. So notice, if you flip undefined, you get 0. If you flip 0, you get undefined. Okay, questions on that one? Okay, that's the last one where I'm going to go through all 6. Okay, the next one, I think I'm just going to do the 3 basic ones. Okay, I'm not going to do the reciprocals. Okay, so I want the sine, the cosine, and the tangent of 3 pi. What haven't they given me here that I really need to do this problem? I need the coordinate. So now I have to figure out, how do I take this and get a coordinate from it? What's 3 pi? What? Somebody explain what's going on with that. John?
Well, it would be -1, 0, the coordinates.
All right, so I think we got a few steps to explain how we got there. But what is 3 pi? I mean, can you explain that to me? Like,
180 times 30.
why? What's this 180 stuff?
Pi is radian.
It's a radian, right? That's an angle, but it's in radians. Okay, so if you are not sure where that would be on this circle, change it to something you're more familiar with. Okay? Change it to degrees. And John, can you remind me again how you changed it to degrees?
3 times 30.
Right. So you multiply by 180, divide by pi. Pi's cancel. And as John just said, it's 3 times 180, which is 540. But now I still think I have a problem. Okay, that angle's big. A lot bigger than I want to work with. So what can I do to make that angle smaller? Yep, go ahead. Yeah, subtract 360. So now I've changed it to degrees. Now I've made it smaller. Now I've got something I can work with. Okay, at this point, I have to know where that is on the circle. And Karen, where is 180 on that circle? You don't even have to give me the coordinate yet. Just tell me, is it at the top, the right, the bottom, or the left? Yeah, it's the left. So now I can see where it is. Now I need to write a coordinate, which is what John said. Okay, what's my coordinate for 180? Yeah. Now we can do everything we did before. Okay, sine is my y. Cosine is my x. And what about my tangent? What is it?
0.
This time it's going to be 0 divided by -1, which is 0. Questions on that one? All right, so the last one I'll let you guys try on your own. Okay, don't find all 6 though, just do 3. Okay, and it's the 3 that I have listed right on the board. So I want the sine, the cosine, and the tangent of 11 pi over 2. Okay, so follow the same steps we did on the last problem. All right, so what's my first step here? What am I going to do first? Yeah, Kyle?
Convert from radians to degrees.
Sure. If you don't like radians and you'd rather have it in degrees, we can do that. So multiply by 180 over pi. And what do you get when you do out that? 990. Okay. So that's a good first step. I don't really want to work with 990 though. That's hard for me to work with. So how can I make 990 easier? Yeah, we can subtract 360. It's still too big. Do it again. 270. Now I need to figure out where is 270 on that circle. On the bottom, and the coordinate for the point on the bottom.
0, -1.
Good. 0, -1. Now we've got everything I need. Katrina, what is my sine?
1. -1.
-1. Yep. Okay. My cosine, how about Shannon?
0.
0. And lastly, my tangent. Well, Brianna? Undefined. Okay, so those are the kind of problems you'll see when they don't give you the coordinate. All right, so the homework tonight's on 116. 11 to 27 odd and 22. Okay, you've got about 7 minutes, okay, before the bell rings. So please try to get started, or do something with the time you have for a little bit. And if you have any questions, just call me over and I'll try to help you out.